Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, let's explore Amazon EKS Auto Mode. I know a lot of you are waiting for this video. Finally, here we go. So as a principal software engineer, I have architected multiple Kubernetes clusters and I am genuinely impressed with Amazon EKS Auto Mode and how it solved the problems with Kubernetes management forever. Basically, everyone today wants to deploy their applications to Kubernetes. Initially, they think it's easy, but very lately they realize the challenges with Kubernetes management. It can be provisioning a Kubernetes cluster, scaling the Kubernetes cluster, choosing the right instance types for their pods, patching, upgrading, and if you're dealing with AI or ML workloads, these challenges just multiply. Because you also have to deal with choosing the right accelerated GPU instances, making sure you efficiently use GPU instances as well, or resources within GPU instances as well. In today's video, let's see what are some of the common Kubernetes challenges and how Amazon EKS Auto Mode address these challenges. It's going to be a very interesting video. I also have a demonstration towards the end of this video. So make sure you watch it till the end. Before we get started, I should thank AWS team for collaborating on this deep dive. Let's get started. Let's start with the first challenge. That is infrastructure management complexity. So when teams decide to onboard Kubernetes or when they decide to deploy their workloads to Kubernetes, they start with day one operations. And as part of day one operations, they decide to provision a Kubernetes cluster. While provisioning a Kubernetes cluster looks simple, it comes with a lot of challenges. For example, defining the size of the cluster. In other words, you also call it as initial capacity planning. Honestly, I have seen a lot of teams struggle with this step because they have never deployed their workloads to Kubernetes. So when it comes to choosing the size of the cluster, that is, should they go with a 3 node cluster or 6 worker nodes for their cluster or maybe 10 worker nodes for their cluster, they find it difficult to understand. To add to it, they also find it difficult to define the size of each worker node of the cluster. Should each worker node be of 16 CPU, 16 GB RAM, or should they spin up worker nodes with more resources? Another challenge while provisioning a Kubernetes cluster is choosing right instance type. When you look at EC2, you can see there are a bunch of instance types. It can be memory optimized or it can be GPU accelerated. It is very important for teams to choose the right instance type because a wrong instance type can adversely impact the performance of application running within a pod of a cluster. And indirectly, it can impact the Kubernetes cluster as well. Some teams also prefer provisioning the cluster manually. This becomes a challenge for them because provisioning a Kubernetes cluster manually involves in spinning up virtual private cloud, creating multiple components within the virtual private cloud. It can be subnets, it can be route table, internet gateway, NAT gateway, and finally provisioning a Kubernetes cluster using EKS within the VPC. So it takes a lot of time and effort to provision a cluster manually. And each step has to be verified multiple times so that the provision cluster is not misconfigured. Some teams might also go with IAC, that is infrastructure as code. Let's say if they choose Terraform, again this involves a lot of effort because They have to take care of state file management. They have to take care of locking, and they have to set up bunch of TF files just to create VPC and EKS cluster within the VPC. Of course, all the components of VPC as well. Now, all this can be avoided. That is, all the challenges with respect to provisioning a cluster is solved by Amazon EKS Auto Mode. Now, how EKS Auto Mode solves these problems? So, EKS Auto Mode provisions a Kubernetes cluster using a single click. We'll also see this during the demonstration. Just with a single click, we can get a Kubernetes cluster, and that Kubernetes cluster is fully managed. Now, this is the important part. So the Kubernetes cluster is fully managed. So you don't have to worry about sizing of your Kubernetes cluster. As you deploy more workloads to your cluster, EKS Auto Mode takes care of sizing your cluster, that is sizing up or adding more worker nodes to your Kubernetes cluster. Not only that, you don't have to worry about the instance type as well, because EKS Auto Mode picks up the right instance type according to your workloads and according to your use cases. So this is how EKS Auto Mode solves the very first challenge with respect to infrastructure complexity. Now let's take a look at the challenges from day two operations point of view. So basically, let's see what are the most common challenges once the cluster is provisioned. A very common challenge is node management. I'll explain this to you with a simple example. Imagine you work as a cloud engineer at an e-commerce company. As a cloud engineer, you performed capacity planning and you decided to go with 3 worker nodes for your Kubernetes cluster. Let's say you sized each worker node at 16 CPU, 16 GB RAM, just for example. So during the weekdays, you notice the application is running absolutely fine and the cluster resources are also effectively utilized. But during the weekends, you noticed sudden surge in the traffic. So every weekend, you see more number of customers access the application. So you decided to go with 5 worker nodes during the weekend. And once the weekend is done, bring it back to 3 worker nodes, just to make sure it's a cost-effective solution for your organization. Also, once in a while, your application runs sale. And during this sale time, you see even more number of users accessing the application. So you decided to scale the worker nodes to 8. And once the sale is done, bring it back to 3 worker nodes. Trust me, there are teams where this scaling is performed quite frequently. Some teams scale up their worker nodes during the daytime and scale down during the night times as well. Now, imagine the amount of time and effort. It can be a cloud engineer or developer managing this Kubernetes cluster. Imagine the effort that it takes to perform this node management. Because when it comes to scaling up, they have to introduce new nodes or maybe a new node pool. These nodes have to be joined to the Kubernetes cluster and pods have to be evenly distributed even on these newly created nodes. And when it comes to scaling down, so the cloud engineer should taint the nodes, basically drain the nodes, make sure pods are shut down on these nodes which are being drained, and all the pods are running on, if you are downscaling it to 3, so all the pods are basically running on the 3 nodes after the cluster is downscaled. Now, as I told you, it takes a lot of time and effort in this node management. Another challenge with respect to day 2 operations is security fixes. We all know how important is security in 2025. So once the Kubernetes cluster is provisioned, it is the responsibility of the team to make sure the Kubernetes cluster is patched with the security fixes. It can be critical vulnerabilities or it can be general security fixes. Another important challenge with day 2 operations is cluster upgrades. Kubernetes timely introduce new versions. For example, you set up the Kubernetes cluster with 1.33.0. You might see 1.33.1 just in a week after provisioning the cluster. You might see 1.33.2, and even Kubernetes once in a while adds new minor version. So you cannot keep this version forever. To make sure you get latest bug fixes and also to make sure you get the new features introduced by Kubernetes, you have to upgrade to new versions. And this might have to be done quite frequently. Finally, another challenge with day 2 operations is making sure the core Kubernetes components are compatible with the version upgrades. So every time you upgrade the Kubernetes cluster, let's say you upgraded your cluster from 1.33 to 1.34 in future, you have to make sure the core Kubernetes components such as CNI, Core DNS, if you're using CSI, these components are compatible with the version upgrades that you have performed. Now, all of these day 2 operations are solved if you go with Amazon EKS Auto Mode. So just like day 1 operations, EKS Auto Mode also solves the problems with day 2 operations. Let's try to understand how. So if we talk about node management, EKS Auto Mode use Karpenter out of the box. Now this is a significant advantage because EKS Auto Mode uses Karpenter to automatically launch and consolidate nodes based on the workload demand. So during your search, Karpenter can scale your worker nodes to 5, 10, or any number as the workload demands. And also Karpenter make sure the resources are effectively utilized. So when the search is done, Karpenter can also downscale your Kubernetes cluster. And when it comes to security fixes and upgrades, EKS Auto Mode provides Bottlerocket based AMIs that AWS continuously patches, tests, and rolls out, eliminating the need of manual node patching as well as upgrades. And when we talk about the core Kubernetes components compatibility, Amazon EKS Auto Mode also takes care of that. So it removes the burden of managing and ensuring compatibility of core DNS components. Again, it can be the CSI driver or CNI, core DNS. The compatibility is maintained by Amazon EKS Auto Mode because they are built in. So this is how Amazon EKS Auto Mode removes the burden of day 2 operations. Another important challenge when it comes to Kubernetes management is cost management or cost inefficiencies. A lot of teams today struggle to optimize their Kubernetes cluster costs while trying to maintain performance or availability of their application. Typically, every company today wants to have their application available and reliable. To do this, at times, teams over provision the cluster. So they might create clusters with more number of worker nodes, or they might set up worker nodes with more than required resources. Another challenge with respect to cost management is rebalancing the cluster. Now, this is very, very important. Now, if you have manually set up the Kubernetes cluster, it is very important to look at resource utilization. And if you see an opportunity, you have to scale down the Kubernetes cluster or reduce the nodes of the cluster to make your cluster cost efficient. Now, both of these challenges are addressed by Amazon EKS Auto Mode. Just like the previous challenges, cost management is also addressed by EKS Auto Mode. How does it do it? We already learned EKS Auto Mode use Karpenter, and Karpenter is best known for rebalancing the cluster. So Karpenter is an open source solution. Amazon open sourced it and they also contributed it to CNCF. So it's a reliable solution where Karpenter always looks at your cluster. It tries to identify the resource utilization, and if Karpenter sees an opportunity, it rebalances the cluster by scaling down your cluster or reducing the nodes of your cluster automatically. Because in EKS Auto Mode, Karpenter is out of the box, you don't have to do anything with respect to rebalancing the cluster. Apart from this, Karpenter attempts to launch lowest cost EC2 instances that satisfy your application requirements. So not only reducing the cost by scaling down the instances, but it also identifies low cost EC2 instances, which is additional advantage when it comes to cost management. Perfect. So this is how Amazon EKS Auto Mode address the most common challenges with Kubernetes management. It can be node management challenges, or it can be cost management, or any other challenges we discussed in this video. Great. Now let's head to the AWS console and see how easy it is to provision a Kubernetes cluster using EKS Auto Mode. So all that you have to do is search for Elastic Kubernetes Service. And once you're here, click on Create Cluster. So you have two options. One is quick configuration, and other is custom configuration. When you go for quick configuration, you have all the options default. So you just have to click on the create button and you have your Kubernetes cluster provisioned. Of course, if you're doing it for the first time, you have to set up cluster IAM role and node IAM role. This is a one-time activity. You can reuse the same cluster IAM role and node IAM role for all the Kubernetes clusters that you set up using Amazon EKS Auto Mode. And setting up these roles are also easy. For example, if you want to set up cluster IAM role, just click on create recommended role and it guides you with the default options. So you can see here, EKS is selected, EKS Auto Cluster is selected. Just proceed with next. All the policies are also selected. Click on the next button and you have the cluster role set up for you. Similarly, node role as well. If you have any questions, you can also look at Amazon EKS user guide for setting up these roles. Perfect. So I'll just go with create option and within few minutes, I will have my Kubernetes cluster up and running. Perfect. So you can see the status of the cluster is active now. Also on the overview tab, API server endpoint is available. If you head to the resources tab, you will see bunch of pods running out of the box on this cluster. And you can guess where these pods are running. So if you expand the cluster section, you will find the nodes. And this is the node created using Karpenter by EKS Auto Mode. So you can see the compute auto mode. We'll also test this. So I will deploy more microservices to this cluster. Let's see if EKS Auto Mode scale the number of nodes using Karpenter. Also on the services and networking tab, we can see default services that are running on this cluster, the Kubernetes service, metrics service, and EKS extension, metrics API. On the storage, you can also see the default storage class set to GP2 and also a CSI driver for EBS as well as EFS. So all the default Kubernetes components are running on this cluster. Typically, the cluster is ready to use. So let's go ahead and deploy a few microservices and test the cluster if it can scale using Karpenter. So I'll use my terminal to update my local kube configuration, basically to use this cluster as the context. Okay, AWS, EKS update kubeconfig --name followed by name of the cluster and region, which in my case is AP South 1. Perfect. So now my context is pointing to Curious Folk Badger, which is this cluster. I'll use an interesting utility. So this is called EKS Node Viewer. If you're new to this, so this is a very cool utility. This shows you the current nodes running for your Kubernetes cluster. This also shows you what is the costing. It helps you understand what is the CPU utilization, current running pods, and the pending pods. So I'll use another tab, and on this tab, I will run OpenTelemetry demo application. You can use any other application. The only reason for choosing this, so this installs almost 20 plus microservices, which will be helpful to understand how Karpenter makes the decision of scaling. So the very first thing is to add this Helm repo. I'll also put the link in the description if you want to try it out. Cool. I already have the Helm repo. Now let's install the Helm chat. Helm install my hotel demo, followed by the chat that we are trying to install. Cool. So let's see on the other tab if, okay, 24 pods are pending, 2 pods are running. The 2 pods are running on which we already had on the cluster. A new node is being created and Karpenter decided to go with M6A.large. So this is what I was talking about, intelligent scaling. It chooses the node type according to the workloads, according to the demand of the workloads. So 24 pods will run on this node and it will utilize 73% of the CPU. All the 24 pods are currently in the pending state. Let's see if it is right. If I just do kubectl get pods -a, perfect. So most of the pods are in the pending state. Only 2 pods are in the running state. Perfect. Most of the pods are in the running state. 23 pods are running. And this node was able to accommodate the demand from the pods. Now let's see if I uninstall this Helm chat, if I try to terminate these pods, will EKS Auto Mode through Karpenter be able to remove the node basically to make it a cost-effective solution? You know, if EKS Auto Mode does not respond to the termination of the pods, then you still have this node running and it would cost a lot for your organization. So let's see, I'll just run Helm uninstall my hotel demo. So you can see CPU utilization goes back to 0. 0 pods are running. And right now, the node is still in the ready state. But let's wait for a couple of minutes to see if this node moves to deleting state. Only if this node moves to deleting state, we can call EKS Auto Mode as cost-effective solution. Till now, we saw how it can help with provisioning. We saw how it can help with node management, that is by scaling the node. Let's also see if it's a cost-effective solution by moving the node to the deleting state. And after moving the node to deleting state, probably it would take 2 to 3 more minutes to completely delete the node. Awesome. So it moved to the deleting state. And just after a couple of minutes, the node is completely deleted. So this shows EKS Auto Mode can completely automate Kubernetes cluster management. So we looked at provisioning the cluster. EKS Auto Mode can automate it. We also looked at node management by deploying a lot of microservices. We saw Karpenter can scale the Kubernetes cluster. And we also saw that EKS Auto Mode is a cost-effective solution because as soon as I terminated the pods using Karpenter, it was able to delete the node. If you want me to make a video on a specific use case, make sure you let me know that in the comment section. And finally, I would like to thank AWS team again for collaborating on this deep dive. I hope you found this video insightful. See you all in the next one. See you everyone.